So welcome back again. Um, Again, this is the third part of our videos for hypotheses tests in Chapter 20 in AP Stats. So we're at the point where we're talking about p-values and some facts about our p-values. Um, Again, to start it off, we're always looking at our null hypothesis when you make your decisions. So always make decisions about the null hypothesis. So again, it'll make more sense when we get to our examples, but again, hopefully you understand when you're talking about your null hypothesis when it comes to p-values, you're always making those decisions based off of that. Now, when you have your p-values being very large, you are supporting your null hypothesis statement, but you're never actually saying that it is true. You're supporting that evidence that it is valid, but it's not necessarily true. So again, it's a little hinky on the wording, so just be careful with that. Now, when the p-value is small, you're showing support that your null is not true. Therefore, again, there's that rejection. So when your p-values are small, you are showing that your null hypothesis is not true. And then we were talking about the not equals earlier. That's a little bit harder because you take your p-value and you double the value. And when you are allowed to do that, if you can double the value, you're looking at both of those two tails, so the left and the right, on that normal curve that I showed you earlier. Then you're allowed to do double the p-value for your two tail. Therefore, you're dealing with not equals tests. And again, I do want to make sure you stress that you're never accepting the null hypothesis. You're either rejecting or failing to reject. So again, rejection or failing to reject. That's it. You're not allowed to say accept. So, make sure I stress that. You never accept the null hypothesis. Never accept a null hypothesis. You're either failing to reject or you're rejecting. So you reject or fail to reject. That's it. Okay, so let's take a look at our p-values for your alpha, and we're going to compare them to 5%, the default. And would you reject or fail to reject your null hypotheses that are given for the given p-values? So if you're given, letter A says 3%. Since 3% is less than 5%, we would reject. Letter B is 15%. 15% is greater than 5%, therefore we fail to reject. Now 45 is very much bigger than 5%. So again, we are failing to reject. And lastly, you have 2.3% versus 5. 2.3 is less than 5, therefore we reject. So hopefully this makes a little bit more sense of what you're supposed to do with your decision making. Excuse me. All right, so let's go on to our formulas, or I should say formula. It's not plural, formula for a hypothesis test. It should look somewhat familiar. We have p hat minus p divided by our standard deviation. Hopefully you remember that. We've been doing that for quite a long time now, although it hasn't been in this syntax here, this version, where you have p hat and mu in the same problem. So again, it's just slightly different, but this is our test statistic for hypothesis tests. All right, so let's talk about calculating what we're supposed to do. One-sided test that's less than is when your p-value and your z, right, the value that we just did, the value that you calculated, your z-test is when the z-test shows that it's less than that calculated value, you're going to have a less than for your alternate hypothesis, your p-value. When your one-sided test is greater than, you have a p-value is equal to, again, your probability where your z-score, that z-test score, is greater than. You see how they're directly related. And again, when you get to the two-sided, that not equals, you must multiply by 2 that calculated value. And again, it has to be less than. So it's 2 times that value. Okay, so again, we've talked about the parameters, we've talked about the hypothesis statements, the assumptions, and the calculations. So let's go to the end now and talk about the conclusion in its context. Okay, so there's 2 things we must do when we're writing conclusions with our hypothesis statements. Okay, the first is we have to make a decision and we have to write about it. So the decision that we're making is a statement of the decision being made, whether you are rejecting or failing to reject your null hypothesis. And then, of course, you're going to tell me or why. So again, that's it. You're rejecting or failing to reject, and you tell why. The second thing you must do when writing your conclusion is actually the conclusion part, where you're making a statement of the results in the context of the problem. But the context of the problem has to be stated in terms of your alternative hypothesis. Again, the thing that you're trying to prove or disprove. So those are the 2 things that you're going to be writing in your conclusion. You need to state whether you reject or fail to reject, and then make a statement of the results in the context of the problem in terms of your alternative hypothesis. Okay, so let's talk about some examples. When your p-value is less than or equal to your alpha, you reject the null hypothesis. Again, remember, there's your 5%. You're comparing it with that. When your p-value is less than that 5%, you reject the null hypothesis at that same level, at that alpha level. Or the other occurrence that you can have is, since the p-value is greater than your alpha, you fail to reject the null hypothesis at that level. Those are the only 2 things you can have. So those are the 2 verbiage, that's the 2 sentences that I'm going to be looking for in your decision making. Then you write your conclusion, and they correlate right well with one another. If your p-value is less than or equal to alpha, where you reject the null hypothesis, meaning your alternative hypothesis is valid, then, or more than likely, there is enough evidence to conclude that the true proportion of blah, blah, blah. So again, this is what I'm looking for. And likewise, when your p-value is greater, there is not enough evidence, because again, you failed to reject it. There's not enough evidence to conclude that the true proportion of blah, blah, blah. All right. Don't forget, again, the conclusion must be written in terms of your alternative hypothesis. Okay, so let's do the end here. We're going to go and start the last video on hypothesis tests about this problem. And I want to go through the whole process on what I'm looking for in solving these type of problems. So, I'll be right back.